All right, so what we're going to be learning today is a little bit about Ohm's Law. Okay, now Ohm's Law states that 1 volt will push 1 amp through 1 ohm of resistance. Okay, this is the equation. Volts equals amps times ohms. Omega symbol is your symbol for ohms. Okay, and a lot of times what you'll see is they'll draw a triangle, or I like to draw a circle. Okay, and they divide it down. And this is just a way that they remember this equation. They put V on top for volts, A down here, ohms down here, and it's just saying volts divided by amps gives me ohms. Volts divided by ohms gives me amps. Amps times ohms gives me volts. Other things you might see in here, especially if you're reading more electrical engineering type books and stuff, is they will use E up here instead of V. E represents electromotive force, same thing as voltage. Down here they're going to use I for intensity, same thing. Amps, sometimes you put C for current, amps, current, intensity, all the same thing. Over here, instead of putting omega, they might put R for resistance, same thing. This is what we will use in my videos. All right, so now that we kind of understand what Ohm's Law is, we're going to use these 3 circuits down here, 3 different types of circuits, and we're going to learn how to solve for variables that are unknown. So up here it says that every battery has 12 volts. Okay, this is the symbol for ground, this is the symbol for battery. So we're going to write 12 volts right there so we remember our battery has 12 volts. Now, the first question it asks us is, what is the total circuit resistance? So in a series circuit, or in other words, in a circuit where there's only one pathway for current to flow, it's very simple to find circuit resistance. It's just simply adding this one plus this one, okay? So 3 plus 9 is 12 ohms. So we're going to write that over here. Now, total circuit current, we're going to come up to our formula. If we know our voltage and we know our resistance, we can find our amperage or current, right? So volts divided by ohms, 12 divided by 12, that gives us 1 amp. Now, the rule in a series circuit, after you find what your total amperage is that amperage stays the same everywhere in this circuit. So if I were to measure amps here, it would be 1 amp. If I were to measure amps here, it would be 1 amp. If I were to measure amps here, it would be 1 amp. So question 3 says, what is the current through bulb 1? Well, we just said that. 1 amp goes through bulb 1. It doesn't change. What about bulb 2? Same thing. 1 amp. Now, voltage drop, or how many volts get used by bulb number 1, we're still going to use this equation. Here's the things that we know about bulb number 1. We know it has 3 ohms. We know 1 amp went through it. And up here we say that when we know amps and ohms, it's a multiplication problem. So 3 times 1, 3 volts dropped on that bulb. What do we know about bulb 2? We know 9 ohms. We know 1 amp. 1 times 9, 9 volts drop there. And then we know we're right because we started with 12 volts and we dropped 3 and then 9, so we used up all the voltage. And that's one of the rules in a series circuit, is all the volts will get used by the time we get to the end of the circuit. Or in other words, each load will drop a portion of the volts until there's no volts left. Okay? Now, a couple conversions here just to get some practice. 315 kiloohms is how many ohms? Kilo stands for 1,000, so we are literally saying 315,000 ohms. 0.440 amps is how many milliamps? Milli is 1,000th of an amp, so 0.440 amps is 440 milliamps. All right, now we move on to this parallel circuit. In a parallel circuit, things change just a little bit. We still have a 12-volt battery, but there's some new rules. There are now 2 pathways for current to travel down, and current will divide down each of those paths. Think of it as a river that has 2 canals or outlets. Some of the water is going to go down this way, some of the water is going to go down this way. Our job is to find out how much. Okay, but the other rule it has is source voltage will go to each branch. So we can come here and say that that branch has 12 volts and that branch has 12 volts. And now I can treat that right there as a simple series circuit, and I can treat that as a simple series circuit. And I can say that 12 divided by 2, using our equation up here, this bulb gets 6 amps. Everything on that branch gets 6 amps. This bulb, same thing, 12 divided by 2, 6 amps. That was easy. Over here, question 9 asks, what is the total circuit resistance? Well, if 6 amps went down this branch and 6 amps went down this branch, how many amps did we start with? 12 amps. So that's our answer. What's our total circuit current? Oh, I'm sorry. This is our total circuit current. Scratch that for a second. Total circuit current was 12 amps. Okay, now that we know that, we can find what the total circuit resistance is, right? 12 divided by 12 is 1 ohm. And notice that the total resistance is lower than either of the branch's resistances. That's something to keep in mind. That will always be the case. When you give current more pathways to go down, you reduce its resistance. Okay? Now, current through bulb number 1, we already solved that. 6 amps. Current through bulb number 2, 6 amps. All right, now how many volts drop right there? 6 times 2. 12 volts, right? That bulb is the only thing on the branch, so it drops all 12 volts. Same thing here. All 12 volts. A couple more practice problems. 518 millivolts is how many volts? 0.518. 8.92 kiloohms is 8,920 ohms. 0.077 volts is how many millivolts? 77. Okay, last one. Not much different here. The only difference is the bottom branch has 2 bulbs on it. But it's the same thing. It's like a mini series circuit inside of a parallel circuit. So we still get 12 volts. We know that each branch gets 12 volts. And now we're going to treat it like a series circuit, just like we did up here. 12 divided by 4 gives us 3 amps. Down here, series circuit. But remember, in a series circuit, we add these 2 together for our ohms. So 3 plus 9 is 12. And then we take 12 divided by 12, and 1 amp is how many goes through each of those bulbs. So over here where it says what was our current through bulb 1, it's 3 amps. Current through bulb 2, 1 amp. Bulb 3, 1 amp. What's the total then? Be careful here. Do not add 1 plus 1 plus 3. Don't do that. What we're adding is branch plus branch. So we have 1 amp on this branch, 3 amps on this branch. So our total is 4 amps. Okay? What's our total circuit resistance? Use Ohm's Law right here. 12 volts divided by 4 amps gives us 3 ohms. Is that lower than our lowest branch resistance? Yes, right there. 4 was our lowest branch resistance. We have less than that, and that follows our rules, right? We will always have less total resistance when you give more pathways for the current to flow down. Okay, last thing. How many volts drop there? 3 times 4, 12 volts. 3 times 1, 3 volts. 9 times 1, 9 volts. Okay, that is how you do an Ohm's Law worksheet. There you go.